Hello, Berlin. Terrorist fist jab. Really happy to be here tonight. The secret talk tonight is I'm going to be talking about the state of the JavaScript language and its specification, how it got to be the way it's about to be, and what it might be going forward. But before I begin, there's one thing I have to say about JavaScript. JavaScript is a proprietary trademark that belongs to Sun Microsystems or possibly to Oracle Corporation. I'm not sure where that deal is. But we're all into open systems here, and so it seems strange that we put this proprietary label on the stuff that we do. And in fact, there's an open label, which is not proprietary, which we can all use, which is ECMAScript, which has actually become the true name of this language. That's what it really is. And we probably should call it ECMAScript, except it's just an awful name. It's really hard to say it, and so there's that. So in describing the standard process that got us to the 5th edition, which I hope will be published next month, Brendan Eich, the inventor of JavaScript, described it as being similar to the motion picture, The Fellowship of the Ring, in which I was Gandalf standing on the bridge at Khazad-dûm, stopping the monstrous ES4 proposal, which he calls the ES4 ROG. My perception of it's a little bit different, and so tonight I'm going to give you an extremely biased story, my point of view of what happened. And my point of view is a little different, and my movie is a little different. My movie metaphor is 12 Angry Men. This is Sidney Lumet's wonderful crime courtroom drama. We don't actually see the crime, we don't see the courtroom, we only see what happens in the jury room, where these 12 men get together, and 11 of them are certain that it's an open and shut case, the kid's guilty, let's cast our verdict and go home. There's one juror, juror number 7, who says, I'm not sure, I think this is wrong, and over the course of several hours, they fight and argue and cry, and eventually he changes everybody's minds, and they acquit the kid. So there you see juror number 7, that was me. And the guy who's about to stab him with a knife, that would be juror number 3, that's Brendan Eich. And in fact, we were all angry men. There were no women involved in this. I don't know why. I think there should be, but there aren't. It's hard enough to get men to come to these things. There were occasions when I couldn't make the meeting, so I send people from my team and ask them to report when it was done, and they said, oh, it was really interesting. I said, would you go again? No, would not go again. Then there was the 13th juror, the alternate, who kept saying, can we speed this up? Can we get done with this? Can we make this go faster? So the place where this was all happening was at TC39, Technical Committee 39 of ECMA. This is where the stewardship of the ECMAScript programming language happens. At the time that I joined TC39, which was about 3.5 years ago, there were no members of the committee who actually used the language. There was nobody who represented you, no one who had ever written a web app. They all knew the language really well because they're all implementers of the language. And the things that they wanted to do with it were things that were going to be fun to do in the implementation. They really had no idea what you needed in order to make the language better for you. At that time, it was a pretty small club. There was Adobe, Mozilla, Opera, and Microsoft. And Opera actually shouldn't have been there because Opera at that time was not a member of ECMA. And ECMA's rules are very clear that only members of the organization are allowed to participate in the meetings. What the committee was doing was pursuing a design that had begun at Netscape in 1999. And in 1999, the problems that we had with the language as we perceived it and the way we used it were radically different than they are now. For example, at that time, there was nobody using the language. And so they were considering pretty drastic modifications to it in order to try to get somebody to like it. That wasn't the case at the time that I joined the committee. Ajax had already happened, the language was taking off, it was hugely popular. And once something becomes hugely popular, your license to make modifications to it is revoked. You have to be much more cautious about what changes you can make. The design that they had begun in 1999 was abandoned early in the 21st century, but when Ajax happened, suddenly there were people using the language, so it was like, oh, okay, there's reason to do this now, so they picked it up again. I wasn't convinced that we should finish this language. I thought it had a lot of deep problems. The first of most was that it didn't solve any of the problems that we had. And in my view, the most significant problem we had was security, that we're constantly menaced with cross-site scripting attacks. And my company and pretty much all of your companies are very much at risk at that. The consequences of those attacks are huge, and they are facilitated by the design of the language. And the ES4 design did absolutely nothing to correct any of those problems. We also have problems with inter-browser compatibility, and the design that they were pursuing wasn't helping us there either. There was strong interest in the web community to make the language suck less, although nobody really knows what that means, and there was not a good way to articulate that. And so the committee's interpretation was any radical change we make is going to make it suck less, which I wasn't confident that was the case. I was concerned that it was actually going to make it suck more by making the language bigger and more complicated without producing any compensating value in return. And we've seen lots of cases where good intentions have proven to be ineffective. So I wanted to bring the committee back to doing good design, but they did not want to hear it. They refused to argue about their system as a whole. They refused to argue about the necessity of individual features. They would consider arguments about errors in specific features, but they wouldn't talk about whether or not we should even have it or not. They claimed that they'd been at work on this for many years, and I'd just shown up, and that they would be done in a year. Essentially, I'd missed the window for proposing changes to the thing, and so it was just done. So that was very disappointing. I was too late to affect the process, but that was just the way it was. However, it turned out that the Microsoft member had similar concerns. So I took him aside at one of the meetings and asked him, what do you really think about this? Because at this point, Microsoft had been so cowed by the web community and everybody that they were pretty much going along with everything. But secretly, they knew that this wasn't the right thing. The guy I talked to was concerned that if Microsoft changed their position on it, then they would be attacked for doing anti-competitive behavior, which turned out to be correct. That in fact happened. But the concern wasn't to be anti-competitive. The concern was to try to do the right thing. And I convinced him that Microsoft should do the right thing. And to his credit, he decided to do the right thing and convinced Microsoft to do the right thing. So we had this big showdown in Redmond at one of our scheduled meetings. It was the biggest meeting we ever had. Everybody sandbagged it, except me. So Microsoft brought in a whole lot of extra people, including the IE team. Mozilla brought in a whole bunch of extra people. Adobe brought in a whole bunch of people. People had never attended the meetings before. They just wanted to have numbers around the table in case we voted on something that there'd be something to keep score about. Prior to the meeting, Microsoft wanted to play hardball. They wanted to set up a paper trail, begin grievance procedures involving the secretariat at ECMO and all this stuff, and I didn't want to have any part of that. It's technical. We're disagreeing with these people on technical grounds. Let's keep the argument technical and not try to escalate it into other areas. And they agreed to go along with that, but we were still polarized in committee, basically as a consequence of the ES4 group saying we're not interested in anything that you have to say about moderating what we're currently doing. So Microsoft took an extreme position saying we refuse to accept what you're doing in whole or in part, which I think was maybe a little stronger than what they should have said. What I think they should have said was, we need to reset, we need to review individually every feature that's going on here based on some new criteria. But they didn't say that, and so that caused some bad feelings. And so the committee was not in consensus now, which was a really bad thing because a standards committee has to be in consensus in order to do its work. So the fellowship was now broken at this point. So I proposed an alternative project, which I called ES3.1, indicating that it would be a much smaller increment over ES3, which was the current specification. It would be a minimalist alternative to the maximal alternative that was ES4. Unfortunately, the argument went public. And when it went public, it went really nasty. Part of the reason why it went public was that ES4 was positioned as the official new standard, and that ES3.1 was breaking the rules, that ES4 had already been approved and 3.1 was trying to undo the system. And that wasn't the case at all, but that was the perception that had been given to the public. There were a lot of accusations made at Microsoft and at Yahoo. For example, Yahoo and me in particular were accused of conspiring with Microsoft in order to protect IE's dominance in the marketplace. And if any of you know my position on IE, you know that's absolutely not the case. We were aligned on this because the technical arguments were right. So I was able to do one thing that Henry Fonda was not able to do, and that was to bring more jurors into the jury room. So I went out and started talking to other companies, and I wasn't so concerned about what their positions were, but that I wanted them to come and join the argument, because my feeling was the more voices we had discussing this, the more likely we were going to reach a consensus, because right now we were divided into two extremes, and that wasn't good. We somehow had to get back to consensus, and my hope was if I could get more parties to join the discussion, we would be able to do that. Many of those companies sat on the sideline, told me privately that they were glad that I was fighting the fight for them, but they did not want to get involved because they didn't want to get tarnished the way that Microsoft was getting tarnished. Sorry, okay. We continued to agree to disagree. That was all we could do. We had formally split into two committees, but continued to hold joint meetings. It was really uncomfortable and it was unproductive. But through that process, eventually other companies joined, including IBM, Apple, Google, Opera, Dojo, and Company 100 from Korea. And it took a while to get all those companies to the table, but eventually we got them and things got a lot better. All through this process, ECMO was really worried. ECMAScript is their biggest product, and it's their hit. Anybody know of any other ECMA standards? So ECMAScript was going out of control, and if they lost that, that would be hugely embarrassing at least, and perhaps monetarily embarrassing. They could not tolerate two proposals. If we went to the General Assembly with competing proposals, both would have to fail. So we got into a race. I'll tell you about that in a minute. So ECMA's Secretary General and ECMA's President both began attending our meetings, which was really good because everybody was on much better behavior now. So a lot of the civility was returned to the process, and it got a whole lot nicer. So with that new spirit of niceness, we started to try to agree to things, to try to get back to some kind of consensus. And all we could agree on was that 3.1 and 4 should have some sort of subset relationship, so that 3.1 should be a subset of 4. But we couldn't agree on what that meant. The ES4 people meant that the ES3 team could only mine features from ES4, that there are so many features in ES4 that anything we'd ever want to do has got to already be in there. But from our perspective in 3.1, we were trying to make the language more secure, and that had not been a goal for ES4, and so we needed features that they had not considered. So our position was they had to adopt anything that we added, and they weren't real happy about that either. So we were still not in consensus. We were not converging. ES4, it turned out, was one of those projects that was slipping a year every year. When I joined the committee, they were planning on having the thing be done and approved in a year. They were planning on having it done well before Adobe Air shipped. That was Adobe's motivation for why they wanted this new language standard. It was going to be the one language in Adobe Air. Adobe Air shipped, and it was still a year away from release, and so on. And eventually they got to the point where it was clear it was never going to finish. So they began jettisoning features, now on an attempt to get back on schedule. So they were finally doing the feature review that I'd asked for at the first meeting, but now the motivation was to fix the schedule, not to fix the design. However, in looking at that, they discovered that there were, in fact, deep problems in the things that they were proposing and the interaction between those things. So ultimately, it was determined that the ES4 design had been unsound all along, and so it was ultimately abandoned. ES3.1, because it was a much more modest proposal, was eventually completed and became a candidate for the 5th edition. We decided not to call it the 4th edition because the 4th edition had already been pre-sold. So there was an expectation as to what that was, and this spec was not going to meet that expectation. So we decided to bump the revision number. ECMO was a little confused by that. There's a 4th edition, but we got that through. So it goes to ECMO's General Assembly next month. We have a meeting at Google in Mountain View, California, and I'm hoping that the General Assembly will vote yes on this, and then we will have the first revision to ECMAScript in 10 years. And that'll be a good thing. One company has stated its intention to vote against it, and that company is IBM. And the issue is decimal arithmetic. You might know, what's that got to do with ECMAScript? Well, it turns out the number one most reported bug in Mozilla's database is 0.1 plus 0.2 is not exactly equal to 0.3. And there are lots of variations on this, but they all come down to the same fundamental problem, which is that binary floating point cannot accurately represent decimal numbers, which is a problem because on our planet, the dominant species uses decimal numbers. And the number system in this language was designed for some other planet, some other race of aliens. They may be really nice creatures, but they're not us. So you would think, if that is the most reported bug, the most replicated bug, that deserves fixing, wouldn't you think? And it does, and we should fix it. So where did the bug come from? It's actually not a bug in the design of ECMAScript. It's an inherent problem in IEEE 754 floating point, which is a floating point system that's used in the whole world, and it's used everywhere. It came originally out of Intel, out of the failed 432 project. And it significantly improved the uniformity of floating point results across different CPUs. Prior to 754, every computer manufacturer, and there used to be lots of them, had several architectures, and each architecture had a different scheme for doing floating point. Different word sizes, different mantissa sizes, different encodings, different exponent sizes, different biases, different rounding modes, all sorts of different radixes. And so writing a program, say in Fortran, that would get the same results on one machine and another was really, really difficult, perhaps impossible. So making it all common was a huge step forward, and this was a really good thing for that. Although it turns out now everything's Intel, so who cares? But at that time, it was an important advance. And it is very well suited to some applications, including applications where you have both very large and very small numbers that interact with each other, which includes astronomy, chemistry, and physics, and lots of other things. But not business applications or anything that involves the level of math that you might have learned in middle school. Binary floating point is poorly suited for most other applications, including everything that we do. So we ought to fix that. And again, the problem is that binary floating point cannot exactly represent decimal fractions. It can handle dollars and quarters, but it accumulates errors on pennies, nickels, and dimes, to use an American metaphor. If you type a number into your program and it has a decimal point in it, you already have an error in your program because that number does not represent the value that you typed in. You're getting something else. Given the applications that ECMAScript runs, IEEE 754 was a really bad choice. But it was also a popular choice because the same mistake was made in virtually every language design completed over the last 20 years. Everybody adopted this thing because it was a standard. Just because something is a standard doesn't mean it's the right choice for every application. So that's a problem that we need to fix, and IBM came up with a proposal for how to fix it, something that had a working title of IEEE 754R for, I think, revision. It adds decimal modes or decimal radixes to 754. It corrects the problems with representation of decimal fractions. IBM tried to get this into the third edition in 1999. The committee at that time said, oh, we'd like to get it, but we don't have time. We'll put it in the next one. It'll be coming out next year. At that time, they didn't know that ES4 was going to take 10 years. At that point, they'd been on an annual schedule, and they figured the next one will come. IBM's been waiting for it ever since, and they think that they were promised this feature and that they should have it. Except that it was ultimately rejected by the ES4 group and by the ES3.1 group. That was one of the few things we could agree on, but we all agreed that the decimal problem is a significant problem and that 754R was not the solution to it, at least not in the short term. Let's look at the beast. So this is 754. This is what Java calls a float. It's a 64-bit value made up of several fields. There's a 56-bit mantissa. There's an exponent which is biased. And the reason it's biased is so that you can use integer comparisons for comparing normalized numbers. That's a value if floating point subtract is significantly slower than integer subtract. So you take the mantissa, which is scaled to be a number between 0 and 1, and multiply it by 2 raised to the unbiased exponent. And that's the source of the problem, because we're raising to a power of 2 and not a power of 10. They came up with this to replace it, what they call 754R DEC 128. So it's now a 128-bit number. So, okay, memory's cheap. That's not a problem. We're just doubling the size of everything. But the encoding is really complicated. It's divided into 11 10-bit fields. Each of those fields contains a number between 0 and 999. And then the exponent has some extra bits in it as well. They couldn't fit them into another packet of 10, so there are extra bits kind of floating around in there. So unpacking all this stuff is really time-consuming. So say you want to add one to one of these. You unpack the first triple, add 1 to it, ask if it gets bigger than 1,000 or 1,000 or more. If it does, you subtract 1,000 from it, store it back, go to the next one, add 1 to it, and so on. 11 times, you know, it's really slow. It is really, really slow. Now, one problem with it is it will produce results that are more correct, but some applications may be dependent on incorrect results. This happens in the web all of the time. This is why Microsoft cannot fix IE, because everybody who's written applications in IE depends on them failing in a particular way. And when they change the failure mode, sometimes by eliminating the failure mode, it causes our programs to break, which is a hopeless situation. And we anticipate there are similar problems in the number representation. We think that it fixes more programs than it breaks, but it does break some programs, and we're trying really hard in the standard business not to break anything. So we're very constrained there. We considered adding a use decimal mode to the language, so that would say, I know the numbers are going to be different, that the results are going to be more correct. That's what I want. I will accept the risk for that happening. And then you can test for it before you put it in, and then we'll know that it's good. We rejected that because the new format is literally hundreds of times slower than the old one. And it was vetoed mainly by the browser makers, who are now working really hard to all make their JavaScript engines go much faster. They weren't willing to add something that was going to slow them way, way down. Now, I think in practice it wouldn't have been that big a slowdown, because mostly we're doing integer arithmetic in this language, and we could have a special case for integers. You know, if it's an integer, we take the integer path, and only if it's a float, do we do this super slow thing? But the browser maker said, no, that was a hardship to them. They didn't want to have to do that, and so that's not an option. So we couldn't do that. We considered adding a decimal library, where you'd say like new decimal and pass it a string, which is what your number looks like. Then you would call that value .add and pass another one, and so on. And it was really ugly and unlikely to solve any of the real problems in actual use, because existing programs are still going to fail in exactly the same way. And I don't think we could get anybody to write programs in this new mode. It's just too ugly. So it was not a solution. We considered adding another number type. But one of the really good things about this language is there's only one number type. And so there's a whole lot of complexity that's factored out. In other languages, you've got more primitive number types in which you have to be aware of what the potential range of the values are and so on. And if you guess wrong, then you're injecting terrible bugs into your program. JavaScript completely avoids that by going to the top of the line number and saying that's the only one we've got. That turns out to be really nice. But now we're adding two of them, so that adds a whole lot of complexity to a language which is currently extremely simple in that aspect. And so that might be a desirable thing, but we really want to make sure we get that right. And we did not have time in the current process, so we still want to consider that, but not right now. So we are looking at trying to seriously do something about decimal in a later edition, because it is the most reported problem, and we do want to fix it. But there are real complexities in this. Now, through all of this, there's been no discussion of more suitable decimal formats. IBM's position has been it's 754R or nothing. Actually, they didn't say nothing. It's 754R, and that's it. So I did some thinking, maybe there's some other options. Did I do that? Damn Firefox and all their updates. So I invented some more decimal floating point formats, because they're actually pretty simple. So this is one I called 9E6. The numbers are 64-bit integers scaled by 9 million. So you take an integer, multiply it by 9 million, and you store it, that's a number. It has some really nice advantages. Addition and subtraction happen at integer speeds, which is the fastest we can do arithmetic. So, and since most of what we're adding, or most of what we're doing numerically is adding and subtracting, that's a really nice advantage. It may actually speed up the current language. It gives you 6 exact decimal digits, which I think is 4 more than we need for most applications. And it gives us a 7th decimal digit, so that basically we represent anything, any integer over 9 million. The nice thing about that set is it allows us exact representation of common fractions, like 1 over 60 or 1 over 360, or 1/3, so that 1 divided by 3 times 3 will be exactly equal to 1 in this language, which is a really nice property. You'd think all languages should do that. No language does that. But this one could if we had this number type, which would be nice. There are some disadvantages. 6 or 7 decimal digits might not be enough for some applications. For example, if you're doing trigonometry, you want to get your sines and get a lot of bits in them so that your rotations come out smoothly. 6 or 7 decimal places might not be enough for that. It's only 24 bits of significance. You might want more. Also, it doesn't have a lot of headroom. The biggest number it can represent is just over 1 trillion, which for most web applications is probably okay. But if you're doing applications which, say, are about the United States federal budget, they're not going to fit. Now, most financial applications at that level are dealing in tens of thousands of dollars or even millions of dollars. So when scaled that way, they will fit. But in whole dollars, they won't. So there are other things we can consider. So here's another format I came up with that I call DEC64. Again, it's a 64-bit number. The mantissa is a 56-bit integer, and the low-order byte is a signed byte, which is the exponent. The nice thing about this is it's really easy to unpack. We get the mantissa simply by doing a left bit with a sign extension, and the exponent we don't even have to unpack. On Intel architectures, we can get at that byte directly. We don't even have to move it out. So it's really, really fast. It's much faster. I expect hundreds of times faster than the IEEE proposal. And it's really easy to implement in software. And if we can ever convince Intel to put into hardware, it'll go really, really fast. It has disadvantages. It's going to be a little bit slower than 96 because scaling of the numbers is more difficult because you have to do repeated multiplication and division by 10, which CPUs know how to do, but it's not as fast as shifting bits. And the range is only 10 or 1 with 143 zeros behind it, which I think for most of our applications ought to be enough. The current number format in JavaScript lets you go up to 308 zeros. I think 100 or so ought to be fine. Okay, so the argument we're having with IBM now is over goals. TC39's goal is to repair the language, not to add IEEE 754R. IBM's goal is to add 754R, not to repair the language. IBM doesn't care about what damage we might be doing. They want us to solve their chicken and egg problem. So IBM has stated that they will vote against any language standard that does not include 754R, including ECMAScript. So this is my appeal to IBM. It is irresponsible to inflict damage on a language and its community to solve an unrelated chicken and egg problem. If your nay vote fails, you will have done nothing except to show contempt for the web development community. If your nay vote succeeds, you will cause significant damage to the web and the open standards movement. If any of you are employees of IBM or friends of the company, please go back to the company and beg them, please vote aye on the vote of the General Assembly next month. So assuming that, that it prevails, we will have a 5th edition. First new edition in 10 years, and it defines 2 languages. And that's just because of the way that we have to write the specs. There's the default language, which is a language which will be built into the browser and which you'll get if you do nothing. And there will be the strict language. I recommend that you use the strict language for reliability because it says that you're opting in to wanting a better language, and some of the worst features of the language you want removed or modified. So for example, we take with out, we change the way this gets bound, we change the way eval gets processed. A lot of things which either cause the language to be slower or less portable or more buggy, we're taking those things out. It's very difficult to change a standard which is as popular as ECMAScript because every bad feature in it has been exploited. The problem with the bad features isn't that they're useless, it's that they're occasionally useful but dangerous. And there are wannabe ninjas out there who found exploits for everything out there, and we don't want to break their programs. Now you might argue they deserve to have their programs broken, and I actually have some sympathy for that perspective, but we have pledged not to do that. So we require people to opt in to the strict mode if they want these repairs. So not use the default language, specifically to the 3rd edition. And then don't write in the default language because hopefully it'll be abandoned in a few years. So we have a new title for what we do at the committee now. We call it Harmony. The code name of the next proposal is Harmony, not ES6, because we don't want to give a false impression or a false promise about something and its likelihood of being, or its sense of inevitability. That would be an evil thing. That'd be like having now an HTML5 project. We don't want to do that again. So Harmony will be built on top of the strict language. And so that will be the core of the language going forward. And Harmony will probably have incompatible syntax. So programs written in the Harmony language will fail hard with syntax errors if run on pre-Harmony browsers. Hopefully the IE6 problem will be solved by the time we get this spec done. If it's not, this is going to be a real short trip because the language will not be usable. So there's a lot of design pressure on it. As always, there's a lot of pressure to suck less for some meaning of suck and some meaning of less. Again, this is really difficult. What some people mean by that is they want the DOM to be better, which I absolutely agree with, but that's not our business, unfortunately. That belongs to W3C. I think today, or yesterday, TC39 had its first joint meeting in history with ECMO, or with W3C. This is long, long overdue. We need to get these organizations cooperating and working together on this stuff, because our fixing the language in a way which doesn't anticipate what the further damage they're going to do to the DOM, it just doesn't fit. So we have to reconcile those things. There's a lot of demand that ECMAScript be more like other languages, that it be more like Java or more like Ruby or more like Perl or pick a language. That's not going to happen. If you want to be writing in any of those languages, I strongly recommend you be writing in one of those languages. I don't think it really accomplishes anything to try to impose those languages on this one. It'll just make it complicated and buggier. Surprisingly, there's pressure on making it a better compilation target. Years ago, we thought the Java VM was going to become the VM of the internet, but it turns out JavaScript is the VM of the internet, because there are a lot of things wrong with the JVM that aren't as wrong in JavaScript. And so we've got Google with GWT or GWT, and lots of other people who are taking other languages and compiling them into JavaScript for execution in the browser. And they've been asking for things to make that easier to do. For example, you might have a language which has control structures that work differently than JavaScript's control structures. And so to make it easier to generate code, you like to have a goto statement. So, hey, can you put a goto statement in JavaScript? Yeah, so I hear some groans from the audience. So the youngsters won't remember, but the computer industry spent 20 years literally arguing about whether or not the goto statement was a good thing or a bad thing. And eventually we figured out it was a bad thing and that we should stop putting it in our languages, and we did that. So to put it back in, I think would be a tragic mistake, because the ninjas would get a hold of it and they go, whoa, look, I can make it go so much faster by doing a goto here, and we don't want to be responsible for that kind of crap. So we're sympathetic with the idea of being a better compilation target, but our first priority has to be to the users of the language as the language. So we don't want to screw it up for us in order to make it better for them. A goal that I have a lot of sympathy with is the goal to make it secure. I still think that's our biggest problem. JavaScript gets a lot of flack for its security problems. It actually comes closer to being a secure language than virtually any other language in current use. There's just a small amount of stuff that we have to fix. The Caja experiment at Google proves that this is true. My own work with AdSafe suggests the same thing. Facebook's FBJS allows third-party code to run on Facebook pages, not iframed or anything. So we know that a small amount of effort can turn this into a secure language. And I'm hopeful that we can factor that into the next editions of the language. And there's also the goal to be better at math, that we really do want to fix the decimal problem. There's some people who want us to have support for general math so that you could have complex numbers. Anybody want complex numbers? Anybody? Anybody know what they are? Yeah, most of those who know what they are don't want them, as I understand that. But again, language designers think it'd be really neat if you could design it so that you could add complex numbers to the language and have them work. And maybe it would, but I don't see a lot of value in it. There's also a lot of demand for big ints, so you can have ints of arbitrary precision that go on forever. The primary use case for those is doing cryptography. You can do public key stuff and that with using big ints, which I think is exactly the reason for why we shouldn't do it. If we make it easy to write crypto routines in JavaScript, then people will. And one thing we know about crypto routines is you should never be writing your own crypto routines, because they're really hard to get right. You want to be using stuff that other people have written that have been very well vetted. So this is another attractive nuisance that we could add to the language that I think would be a mistake. One thing we probably will do is correct the block scope problem. some enthusiastic applause over there. JavaScript does not have block scope, which would not be a problem except that its syntax says that it does. And so that is a big source of confusion for programmers coming from other languages. For example, it causes them to put their var statements in the wrong place. And so we'll probably fix that by adding a let statement and a const statement, which will replace var, which will be block scoped. So there you go. We'll probably have better support for functions with variable numbers of arguments. The arguments array thing is awful. There's some new syntax that we could add which would make it much better, and we'll probably do that. There's a lot of interest in adding some sort of syntactic language or syntactic sugar to the language in order to add class-like notation to things, but have it map onto the current language. It might be possible to do that with macros, so you could define your own language at any level, and that would be easy, and then we could get out of the way of that. But the committee is wary of macros, so we're probably not going to do that, and we'll try to figure out some other way. One other way might be to use functions to wrap things, so we use the classes as closures pattern. But there is one problem with that, which comes out of R.D. Tennant's book, The Principles of Correspondence, that was published in 1981, which doesn't get a lot of attention today, but there was one particular principle that he outlined which is very attractive. And that is the principle of correspondence, which shows the correspondence between variables and parameters. So here we've got two functions, booga and wooga, which do exactly the same thing, except booga represents x and y as variables, and wooga represents them as parameters. But in all other respects, they're exactly the same. So that's sort of an interesting thing. To a minimalist, it might say, well, we don't need variables in the language. We just need to keep nesting our functions, which may or may not be the right thing to do. But one of the attractive ideas that comes out of this is that maybe we could take anything and wrap it in an immediate function, because there's some benefits that come from that. Except we don't have full correspondence, because there are disruptive statements like break, return, continue, and throw, and implied parameters, this and arguments, whose behavior change if you put them inside another function. And that change of behavior would cause an error. And so there's been argument that we should remove all of those things from the language, which I don't think we can do. Tennant himself does not demand that the language have full correspondence. He just uses it as an analytical tool in talking about languages. Another proposal has been that we add a second kind of function in which the meaning of those things don't change. But I think that's adding way too much complex subtlety to the language. I think that's asking for trouble. Now, Tennant does say a couple of specific things about programming language design, which I think are really useful. Many existing languages manage to combine countless features into a jumble that is neither easy to implement nor a pleasure to use. He said that in '81. We've kept that up pretty well. He also said, side effects are often confusing to program readers because they are unexpected. The familiar expressions of conventional arithmetic and algebra do not have side effects. So Tennant might be saying that we should not have put getters and setters into ES5, but we did. So we don't always get it right. So 10 years, anybody think that was too long? Am I the only one? Yeah, maybe. I think actually 5 years was about right. The reason Ajax happened in 2005 and not in 2000 was it took that long to flush the really bad browsers out of the market, to get Netscape 4 out and to reduce IE4 and IE3 to acceptably small numbers. It was only when IE6 had absolute dominance that Ajax became viable. So a lot of people in our community are angry at Microsoft for having neglected the browser for so long. My view is it is the best thing they have ever done. Doing nothing for 5 years is the best thing Microsoft has ever done. Maybe 10 years was a little too long, but I think 5 years was about right. So let me wrap up with some lessons that I derived from this standard experience, and maybe these will make sense to you. We need a clear separation between research and standard setting. I'm a big fan of research. I'm a big fan of standard setting. I even believe that the same people can do both, but nobody should be doing both at the same time. A standard is the last place in the world where you want to see innovation. We shouldn't have any risks or uncertainty or doubt. We should be absolutely clear on what we're doing, because once you set a standard in place, you really shouldn't be changing it. Don't promise what you can't deliver. At this point, the 5th edition is just a candidate, and it may fail next month. So I'm not here promising that that's what you're going to get. I think it's likely that it will succeed, but it could fail. Maybe IBM will be successful in voting us down, or maybe between now and then some very smart reviewer will find some tragically horrible bug in the spec and we'll have to withdraw it at the last minute. If in fact there is such a bug in the spec, I hope in fact he finds it before it goes to the General Assembly so that we can withdraw it. Because once something gets approved as a standard, it's really hard to take it out. I'm pretty confident that we don't have that bug in there, but that's a possibility, and so we need to admit that. A change to a widely used standard is an act of violence. So any changes that we make have got to be worth it. Changing a standard should involve the same trade-offs as surgery. We want to cut somebody open. That generally isn't a good idea, but you might do that if there's some compensating benefit, or if the risks of not doing that are greater than doing that. Those are the sorts of difficult choices we need to look at when we propose changing the standard. Anything which is a trivial or cosmetic fix, probably we shouldn't be messing with. If you have a great idea, don't tell a standards body. Instead, implement it, show it to the world, and if the world says, yeah, that's right, then obviously that should go into a standard. I see a lot of people trying to do that in the opposite order, and shouldn't do it. We don't want to be taking those sorts of risks in the standards. We need proof first. Standards are hard. They're really hard work. They require tremendous care and precision. And fortunately, we have amazing people working with us who are able to read the specifications of how machines work and run those machines in their heads and figure out where we got it wrong. And we are blessed to have people like that working with us. We are blessed to have people like Alan Werfsbrock of Microsoft, who's our editor, who's done an enormous amount of work in cleaning up the specification. It's a significantly higher quality document than the 3rd edition was. We're hoping that the next edition will be even better. You can't please everybody. This gets back to the hard thing. There are going to be expansionists who have really good reasons for why they want to grow the language, and the reasons are good. But at the same time, they're going to be minimalists like me who say, no, we should not be changing at all unless we have profound, compelling need to do so. And somehow we have to find consensus. And that's hard. But that's sort of the core about what the whole standards process is about. I see a lot of standards bodies that don't do that adequately. Instead, they do a pork barrel thing, where if you support my stupid feature, if you agree not to argue about it, I'll support your stupid feature. And we'll both get our stupid features in, and we can both feel proud that we got something done. I'm very happy to say that TC39 currently is not acting in that mode, but I see other bodies that do. Check your expectations. The process can produce heartbreak and disappointment. I've talked to people at IBM and at Adobe who both described their experience with TC39 as betrayal. I've heard people say they were betrayed, there was betrayal. There was no betrayal. They came in with incorrect expectations. They thought that they could get a specific outcome, and you can't. You can't have that expectation. The best you can hope for is that you can get a consensus on what you want to do. And that's not necessarily going to be the thing that you wanted everybody else to do. There are going to be some trade-offs, and there's going to be disappointment. And you need to understand that going into the process. You also need to check your motives. I see sometimes people wanting to get into the standards process in order to show off. If I can come up with this really complicated feature and get it into the spec, then I'll be famous. I'm the guy who put that feature in. That's my feature. We really don't, that's not how we should be doing things. I've also seen people who get into power trips. Like, if my feature gets adopted, Microsoft will have to implement it. They will have to bow to my will. We shouldn't be doing that stuff either. We've also seen cases, not at ECMA, but in other standards, where one of the parties to making the standard is holding a patent on the thing that he's proposing be adopted and does not disclose that. And the patent gets approved, and now everybody who uses the patent is snagged by that and is on the hook and has to pay him off. And that should be criminal, but it's not. A lot of patent or standards bodies now have rules against that. Unfortunately, they only apply to the members. They don't apply to the world. So the rest of us might put a feature into the standard in good faith, and it might turn out that some third party unrelated to any of us has a patent, and everybody gets screwed. And there's no solution to that problem. Patents and open standards are fundamentally incompatible. And I think the solution to that is to close the patent office. I believe that the success of an enterprise should depend on the quality of its goods and services and its ability to execute efficiently, and not on a capricious government office, which is how it currently works. So some companies think it's attractive. Wow, if we can get a patent and if we can snag one of our competitors, it's free money. And who would say no to free money? Except it's likely that your competitor is also going to snag you on something, and maybe some patent troll is going to get both of you. So it's like gambling, and you hope that in the long term you're going to win, but actually in the long term you're probably going to lose. The patent system made sense in the 18th and 19th century. It really had a fundamental impact on industry and the sharing of ideas and helping us to develop the world that we live in now, and it was a good thing then, but it has long outlived its usefulness, and it is now a detriment and a barrier to progress. So in the patent system, nobody wins except the lawyers. So I want to get rid of it. One of the main reasons to be in a standards process is the satisfaction that comes from getting a lot of people to agree on anything, particularly on something good. That is a wonderful and a valuable thing. And so that's the good thing that comes out of patents. So ECMAScript, the 5th edition, is coming soon. It will be the best web standard in the history of the world. There's still lots and lots of room for improvement. We're by no means done yet, but I think we've made a good start on it, and I hope that we can be an influence to other projects as well. I expect that the future editions of ECMAScript will be even better, even if they still suck a little. Thank you, and good night. So I think we have time for some questions. Yeah? Okay. Anybody? Yes.
You mentioned the importance of having implementations before standards. And you talked about some of the decimal ideas that you had. Are you actually doing any implementation there to prove those out?
I have not. These are paper proposals at this point, just to suggest the possibility of considering other formats. There may be more mature, better thought through formats that I'm not aware of, and I'm hoping that by starting this discussion, we'll find those. So I'm not advocating any particular type. I'm advocating opening the debate to better possibilities. If it turns out that we can't find any, then the next obligation on me is to start implementing these things and trying to prove if they could actually work in this environment. Anyone else? Over there. Yes. Why did we remove arguments.call.e? We wanted to remove the whole thing. but we couldn't do that. The Caja team at Google was concerned about the potential for capability leakage through arguments.call.e. One of the reasons we're adding the strict mode is to reduce the cost of Caja and to reduce the likelihood that you're going to somehow get access to some capability that you should not be getting at. So removing arguments.call.e was an important step in doing that. The language does provide a way of, several other ways of supporting recursive functions, and you'll just have to use one of those. Anyone else? Yes. Mm-hmm. I don't know. That's not an option that IBM's been presenting to us. IBM has not been presenting that option to us. The only option they gave us was the 128-bit format. Good. That's very encouraging. Okay, anybody else? Yes. Actually, ES5 strict mode looks a lot like the good parts. The good parts turn out to have a lot of synergy with Caja and with the new design of ES5. So the struggle for us was how many bad parts could we remove? And we didn't remove nearly as much as we wanted. For example, we still have semicolon insertion. The browser makers told us that it would be a hardship for them to fix that. So watch your semicolons. Yes? So when will it hit the streets? Parts of it have already hit the streets. For example, high-speed JSON parsing is now built into IE8 and to Firefox. Firefox already has the new array methods and a few other features. We don't know yet who's going to be the first to market with the whole language. My guess is that Microsoft is probably a little bit ahead right now, but they can't ship until IE9, and who knows when that's going to happen. So they're pretty constrained in that. My guess is that Firefox is going to play tortoise and hare with Microsoft. So they're going to wait until it looks like Microsoft is getting to the end, and then they're going to go really fast and try to beat them to market. We're trying to convince them that they should beat them really, really good, but we haven't seen that. Apple was involved in all this stuff, and when I ask them what their intentions are, they say, we can't comment on future product directions. And the Google team has been telling us, we'll do whatever Apple does. So we're trying to get them to hurry it up too. Yes? JSLint should look exactly the same. If you're in the good parts, then that should work really well in the strict mode. There's one of the things that we tried to do in the design of this language is not add any new syntax. Because if we have new syntax, your programs will fail on the older browsers. And so that doesn't really do you any good. Look at this new feature that you can't use for 5 years. So we tried to put in features such that you could either test for their omission, or in most cases, your Ajax library could fill them in for you. So for example, if you're using the JSON2.js for your JSON parsing, when you're running on one of the newer browsers, there's no change except your JSON parsing gets really fast. And we can do similar things for a lot of the other array methods and so on. Okay, are we all done? All right, good night, folks.